Hi everyone, I'm Kirsty Yates. I'm from the Australian National University and also an agroecologist with Soils for Life. So it's great to be here and to be able to share some of the information about landscape function today. What I'll be covering is often we think about landscape function in terms of really large scale landscape processes, and indeed they are, but I will be focusing more on paddock scale or plant scale, so at those finer scales and those areas that we most tend to impact in terms of our management. A lot of the discussion will focus on thinking about where do resources accumulate in the landscape and what are some of the processes that drive that. So we'll be talking about soil type, about water, wind, and of course the role of biota in those environments. And so to begin with, let's talk about soil type and soil water. And so most of us will be familiar and can think about areas in our own landscape where the soils look quite different, where the plants growing in them are often quite different. And we know that soils play a really important role in how responsive the landscape is and how water interacts and moves across the landscape. So within this image, we can see these red spaces are areas where we've got a sandier, lighter soil, and these areas through the middle, we've got drainage lines. So we've got a heavier clay soil and in those sort of lower parts of the landscape. So to begin with, we're going to focus on these sandier soils. Here's an image of that sort of landscape. And what we see with the sandier soil is that water more quickly will infiltrate into that soil. So it's got larger particles, so water can flow through, and plants are more able to respond to the wetting of that soil much more quickly. On the flip side, the water can drain very easily, and also those landscapes can dry out much more rapidly. So in these sort of drainage lines, what we see is areas, it's a heavier clay soil, so it takes a lot more for the water to actually soak in to the soil. This particular area is vertisoil, so we've got those deep cracking or swelling clays. I often hear about people joking about losing shovels down into these, so we know that they can be incredibly large, and so it takes a lot of water to actually fill up those zones to start wetting the actual soil itself and to be making water available to the plants that are growing in those soils. With our heavier clay soils, we need a lot more moisture in them to really wet them up and get that plant growth coming through. On the flip side, the water, it takes a lot longer for those types of soils to dry out. So these parts of the landscapes will be much slower to respond to wetting events. They'll need more water to generate a response, but they also would last a lot longer in terms of it'll take longer to dry out. So we know that soil texture and type can vary across the landscape. So as I've said, sandier soils, rapid water infiltration, rapid response, but also rapid drying. Heavier clay soils, slower wetting, slower plant response, but also slower drying. So if we think about how that might play out in terms of our own grazing management, for example, we might think about the way that moisture will play out with plant growth and the interactions with grazing. So it's likely that later in the season, we'll be able to potentially graze for longer on greener pastures in those sort of wetter regions. So thinking about the structure in our landscape and areas where resources are lost and accumulate, patches of those areas that tend to accumulate resources, they have living things, water will accumulate there, nutrients will tend to accumulate there. Whereas interpatch spaces are those areas where resources are often lost, and there's often less fewer organisms living. Those are areas that we're more likely to see wind erosion and water erosion. And it's those spaces that will also have a really big impact on the broader function of the landscape. So the arrangement of those patches and interpatch spaces. So this image, in this image, if we look at the red arrows, we can think about those as being indicative of wind, clearly. And so wind will tend to swirl around the landscape at these fine scales. It'll pick up litter and soil sediments in the landscape and move them. So in this particular landscape, we can see pretty clearly that that litter and is sort of getting embedded and getting stuck in that little patch in the middle. So we can see that patches help to accumulate resources because it can interfere with that wind. And if we look at the blue arrows, which represent water, so we've got water moving mostly through those large open interpatch spaces where there's not much growth happening. But again, we're seeing these patches interrupt that process and provide a space where that water will really slow down, where those sediments and leaves will stop and accumulate. So they'll end up stuck in that little space. Excuse me. And so we have these regions in our landscape that are tending to lose resources and areas or bands that are tending to capture and accumulate resources. And this is a really important part of these landscapes to support living, the development of the living parts of the landscape to support and reinforce those aspects, and to help support more advanced plant systems and more resilient plant systems to sort of grow and generate and push out from those patch spaces. So just to take a closer look at water, on the left here we see what we consider a highly functional landscape. So you can see it's got pretty good ground cover, and even though there are some exposed areas that we don't have those little shrubs growing or grasses, we can see that water does move through those areas, but it tends to spread out and sort of hits those vegetation sites and starts to slow down and sink in. So we've got water is captured, and as water is moving through the landscape, any sediments or litter or anything that picks up is also being captured in those sites. So we've got that lesser or smaller amount of movement of resources across this particular landscape, and where they do, they tend to accumulate in those small zones where you've got the living organisms happening. On the right-hand side, we've got a more dysfunctional landscape that's got these exposed or large interpatch spaces. And what we can see here is as the water's moving through the landscapes, it's starting to accumulate and and coalesce. And as it does that, the energy is picked up, and we can see that we've got that sort of erosive channel coming through that's moving sediments away from that area. So we've got an active erosion sort of going on here from the water, and we can see that that's being lost. And so some of those may end up being accumulating within that sort of grass verge, but of course the grass verge has to be stronger in order to cope with that faster pulse of water that's now moving through. So this is an example where we can see resource loss through wind in particular. So if you have a look at where these plants are, you can see that there's a little terrace around those. So we might have some amount of accumulation, but by and large, we've got these large areas where there's nothing growing or very little that looks to have lost quite a fair bit of soil off that soil surface. So it's likely that, where plants are sitting there, it's held onto that soil and then it's been lost from those regions around that. So it's really important to remember that wind erosion really starts at fine scales. So if we think about this as just a sort of 10 centimetres high, as wind moves through, it starts to pick up particles and moves them across the landscape. And as that particle moves across the landscape, it sort of bounces, and as it lands, it kicks up a little bit of dust. And that dust is often your clay particles, it's areas, it's really fine organic matter, and it's the most important part of your soil in terms of accumulation of nutrients and the capacity to support life. So those parts are often being lost to that dust. And we see that as that wind picks up and as it moves across those landscapes, bouncing and generating more and more dust, that we can have quite a significant loss of capacity in that landscape through those processes. And so you can see even here how particles are sort of, holding onto sediments as some of the soil's being lost as they creep across the landscape. So when we think about these sort of processes, it's really important to understand that, as a wind moves through a really big open space, it picks up a lot of energy. Whereas if you're, sheltering within a stand of trees or shrubs, that it's often much calmer than what it is in the sort of surrounding open spaces. So these kind of processes happen at really fine scales as well. So even in this landscape, we've got quite a sparse amount of vegetation. But even this sparse vegetation is helping to lift some of that wind and reduce some of the energy of those winds at that really fine scale. So we are seeing some evidence of loss here, but we're also seeing, crusts forming, and we'll talk a little bit more about crusts in just a moment. So in terms of our grazing management, we're thinking about how much cover we're happy to remove through grazing, or that we want to retain. It really is important to recognise the role that standing vegetation, whether it's living or dead, even at quite sparse scales, plays in hanging on to nutrients and hanging on to those soils within these really dry environments. So in terms of wind erosion, putting all of those processes together, we've got, as wind moves across the landscape, it can pick up, and we can see siltation with that dust that's being released from the soil surface and losing all of our soil nutrients in particular, and carbon. And we see the role that foliar cover, so how much ground cover, so the relationship between the exposed areas plus the ground cover can reduce that wind erosion. The vegetation height, you can see here that the wind is sitting up above the tree heights. The more roughness that we've got within our landscape, so having dispersed, even if they're quite dispersed shrubs and so on, that help to interrupt that wind and slow down the wind movement and create sites that can capture some of those sediments. And of course, we've got soil crusts that I'll spend a little bit more time on, that play a really important role in terms of hanging on to the soil that's already there. So soil protection, so we've got crusts that form in two different ways. We've got sort of physical crusts, so we can see here that as water's come through this landscape, it's sorted and settled out. The heavier parts of the soil have sunk to the bottom, and the fine clay sediments have sat on top and formed this crust that's less likely to be lost to wind erosion. Within this particular landscape here, you've got that cracking in the clays that you can see, and these play a really important part in terms of supporting moisture to move into that profile and to start to contribute to life. And you can see under this this piece of crust that we've got some, I think it's fungi. And so we've got really important biological life processes that are starting to happen there. So we also have biological crusts, and so many of us will be really familiar with when we do get rain across our landscape, how the whole surface of the soil seems to turn green for miles and miles. And what this is biological organisms. So we've got cyanobacteria and other organisms that are starting to photosynthesize. So they will start to accumulate sugars through photosynthetic processes. And many of these organisms, for example, cyanobacteria, will start to accumulate nitrogen in the landscape. So they play a really important process, firstly in holding on to the soil, but also in terms of trying to start that process of slowly accumulating nutrients and supporting the capacity for higher life forms that are more valuable in our production systems. So this particular landscape, you can see in this little patch of grass here. We've got the interpatch space at the back where there's really not too much going on. So we're going to zoom down into this little space down here. So this has just started to have moisture. So the rain's only just started, really light rainfall. And when we go down, we see this, the surface of the soil kind of coming to life. So we've got quite a few organisms here. These little white organisms, and you see the dark green, and there's a couple of different colours coming through the sides here, which might reflect different organisms or communities of them. So this is actually quite a diverse picture of biological crust that we've got here. So it's likely to be quite an advanced biological crust. And so as I mentioned before, we've got the photosynthesis happening, and so we see that with the greenness as the landscape starts to turn green. These organisms are starting to accumulate nutrients, and they're also supporting the capacity of the water to start breaking through those more physical crusts and start to enter the soil and create that space where more life forms can really start. So these processes happen really slowly, but they're a really valuable part of the protection of the system and the expansion of environments that life can sustain itself. So in terms of our grazing management, thinking about these sites as being really valuable and to the extent we can, preventing damage to them, or making sure that where we are trying to make changes in our landscape to improve water infiltration, for example, that we see these as being an important part of that process. So here's another area. It's got a much less diverse range of organisms. And I think it's really important to recognise in the landscape. So just through this area here, we can see that there's really no infiltration there, that the moisture is just going to hit that and move off. And as we move down into these slightly lower parts, we can see more cracks in the soil. So there's a little bit more water that's going to infiltrate. And we can see that it's obviously flowing through this area. It's a bit lower. And because it's staying moist for a bit longer, we can see this curling where the cyanobacteria are starting to form, and they're building a biological crust on the soil surface, and they're starting to form aggregates at really fine scales. And so this is the development of soil structure happening at really fine scales through our landscape. So I think it's important to be able to see those differences in your landscape and to really look out for where these areas where biological crusts are forming, because it is landscape that's repairing slowly, but it is happening in that landscape. So just looking at this picture here, do you see where resources are being lost or where they're accumulating, and why might that be the case? So obviously there's quite a lot of shrub cover and small trees that we've got through the back here that are helping to keep wind off the soil surface. But when we look really closely at the soil surface, there's large areas where there's not too many plants growing, but there's been just nearby some remediation for sort of water spreading and to slow that water down. And we can see that that's been pretty successful, because as the water's moving across the landscape, we've got these little piles of sediment that are forming and creating additional surface roughness. So that roughness helps to hang on to nutrients and sediments and water, and helps to, when they do start moving because of water or wind, helps to create spaces for those to be recaptured and to support plant growth. And you can see sort of along this little pile of sediment that we have got just on the back side of that, some more plants and things coming up. And you can see right through this landscape, we've got those little rows sort of starting. So by and large in this landscape, resources are being accumulated in patches, so they are still on the move, but often it appears that much of that's being held on to. So in this landscape, we've got much larger interpatch spaces, and you can see in the soil there that there's not a lot going on. There are still some cracks in the soil surface that allow some moisture to penetrate, but they're not particularly deep. And so around this tree, you can see that life is starting to accumulate. You've got more plant diversity in that little region, and as the water accumulates in that space, those biological activity creates space for more water to infiltrate and accumulate, and so starts to support more and more living organisms. And when landscapes are regenerating, those patches will start to disperse and spread out. So when it comes to these interpatch spaces, you often can't change the middle of them, but you can work out from the edge and start to close those gaps. So just in summary, what we've talked about is how different soil types will respond differently to wetting events. So thinking about those areas that need heavier rainfall and how they respond and then take a lot longer to dry out. So with your clay soils versus areas that with lighter rainfall, you can get that responsiveness and plant growth coming from those. Wind and water create zones of loss and accumulation. And so looking at your own landscape about where are the areas that are losing resources, so losing water, losing nutrients, where are they accumulating, and recognizing that these are processes that we often look at and see at large scales, but they occur at small scales, and often our interventions are making really important difference at that small scale. We see in landscapes that biological processes create winners, so spaces that do better at accumulating resources. And so they need that protection as they'll start to support the expansion of those resources, of those living parts, those functioning patch areas to sort of move out. So obviously protecting ground cover does make a difference, but I think the point I'm trying to make here, or something to really keep in mind, is actually ground cover, no matter how small, makes a really big difference. So living is best, but any cover helps. So standing dead matter plays a really important role. And also that soil biological crusts play a really important role in terms of hanging on to resources and preventing them from being lost, but also accumulating resources in the landscape. So I will leave it there. If there are any questions, please feel free to get in touch with me. There's one of my email addresses there, and I wish you all the best. Thank you.